Module 5, problem number 7. The following data represent the muzzle velocity in feet per second of shells fired from a 155 millimeter gun. For each shell, 2 measurements of the velocity were recorded using 2 different measuring devices, resulting in the following data. So I just wanted to clarify, our population is population A, population B. One is from each measuring device, and then our observations are n equals 1 all the way through 6. Observations 1 through 6. So part A, why are these matched pairs data? Well, the same round was fired in every trial. That's not the point. Each observation is its own round. So that we know it's not that one. 2 measurements, A and B, are taken from the same round. That could be, let's just double check the other ones. All the measurements came from rounds fired by the same gun. That's not necessarily true. It talks about, well, it does say that they're from the same gun, but that doesn't impact if it would be matched pairs data or not, because we could be doing anything from the same gun. And then part D, the measurement A and B are taken by the same instrument. Well, they're not. Remember, we have instrument A and instrument B. So let's go back to part B. 2 measurements, A and B, are taken from the same round. So remember, each round is 1, 2, 3, 4, 5, and 6, and then we're measuring it by instrument A and instrument B to compare those two. So the answer is B. All right, is there a difference in the measurement of the muzzle velocity between device A and device B at the alpha equals 0.01 level? Note, a normal probability plot and box plot of the data indicate that the differences are approximately normally distributed with no outliers. They just add that in so that we know we don't have to do the checks to make sure that we can use this. What is your conclusion regarding the null alternative? So let's go ahead and open this data set up in StatCrunch. So here we have the observation number, instrument A and instrument B. Remember, our 2 populations are A and B, and each of these are the observations or the sample within that population. So now in this case, we are looking at an average of matched pairs data. So that means we're looking at the mean and it's matched pairs. So we're going to go to stat. Remember, we're going to go to t-stats, and you see there's 1 sample, 2 sample, or paired. 2 sample is for independent data. This is matched pairs, so we're going to go to paired. Because it's, and not only that, it's implied from the fact that it's paired data that you know it's a 2 sample test. You can't have paired data with 1 sample test, just in case you forget where to find this when you're looking around StatCrunch. So we have sample 1 is column A and sample 2 is column B. So just to reiterate, it says, is there a difference in the measurement of the muzzle velocity between devices A and device B? So there, it's not saying if it's greater than or less than for A and B, it's saying, is there a difference? In that case, we know that our alternative hypothesis is going to be does not equal. If it said, does instrument A measure slower than measurement B or something along those lines, then we would change this to greater than or less than depending on what the question was. But in this case, they're just asking if there's a difference at all. So now again, we have sample 1 is column A, sample 2 is column B. Hypothesis test is checked. Our alternative hypothesis is set. Let's click compute. We get a p-value equal to 0.2661. And remember, our alpha is 0.01. So if our p-value is less than alpha, then we would reject the null hypothesis. In this case, however, our p-value is greater than or equal to the alpha. So we know that we do not reject the null hypothesis. Okay, so the next, excuse me, I keep forgetting to hit continue. The part C, construct a 99% confidence interval about the population mean difference. Compute the difference as device A minus device B. Interpret your results. So let's go back to StatCrunch. We're going to go to stat, again, proportion stats, excuse me, t-stats, paired. Sorry about that. So here we have A and B again, and now instead of doing the hypothesis test, we're doing the confidence interval. And it said to do 99% confidence interval. Let's make sure we put 99.99. Click compute. So now we have the lower limit. I'm just going to write this down to 3 decimal places. We have 12.243, as you can see, right? Oops, excuse me, 244. I'm sorry about that. 244. And over here we have 6.5 444. Let's type those in. Negative 12.244 and 6.444. Check answer. Well done. All right, continue. So here it says, choose the statement that best agrees with your interpretation of your results. So first of all, this one kind of helps you. It says, I am 99% confident that the mean difference in measurement lies in the interval found above. This one kind of gives it away by the fact that it just talks about 99% confident. The rest can say, I'm 19% confident that the mean difference in measurement is 0.01. We're not looking at an exact value here. Remember, we're looking at an interval, so our interpretation is going to have to do with an interval. C is, I am 1% confident that the mean difference in measurement lies in the interval found. And then part D is, I am 19% confident that the mean difference in measurement is 0. So again, we were building a 99% confidence interval, and we remember from when we first studied confidence intervals, that means that we think that we are 99% confident that that mean difference, the statistic that we're looking at, falls within that interval. So let's click on A and check our answer. All right, excellent. So that's how you do number 7. If you have any questions, let me know.